So in this lesson, we're going to learn how to apply properties of similar triangles to solve for missing lengths. So looking at this example on the front, this is a really simple one. So if we know that triangle ABC is similar to DEF, we know that the corresponding angles are all congruent. We also know that the ratios of sides are equal. So for instance, 5/10 should equal 10/20, and that should equal 15 over whatever this side is. So since we know that the two triangles are similar, we know that the sides are proportional, and then what we can do is we can just take this part of the equation and we can solve for the missing side just using cross multiplication. So for instance, 10 times x is 10x. 15 times 20 is 300. And then we can just solve this equation, divide both sides by 10, so x equals 30. So knowing that the two triangles are similar, we can set up these ratios and just cross multiply to solve for a missing side. So let's take a look at some other examples. So looking at example 1, this is a word problem. It says campsites M and N are on opposite sides of a lake, and a survey crew made the measurements shown in the diagram. So they measured this distance, this one, and this one. So first of all, we need to figure out how these two triangles are similar. Well, one thing I know is that these angles are congruent. So angle MLN is congruent to angle ELD. And the reason is they're vertical angles. And then since that angle is congruent, we want to check if these are similar by side, angle, side, since this angle is the included angle of these two sides. So what we can do is we could match up the 55 with the 44 and the 70 and the 56. So the reason I don't care about the 50 is because in order for these to be similar by side, angle, side, it has to be the two sides and the included angle. 50 is not an included, or is not one of the sides that we need. So checking our ratios here, I need to check that 55 over 44 equals 70 over 56. So when I put this in my calculator, I get 1.25, and 70 divided by 56 is also 1.25. So that means the sides are proportional. So they're similar by side, angle, side. So since we know that these two sides are proportional, now we can use the fact that the triangles are similar to solve for the missing length. So it's asking us to solve for the distance between the two campsites, which is MN, which is this side length here. So that's going to match up with the 50. So that's where we're going to use the 50. So setting up our ratio, we can use either the 55 and the 44 or the 70 and the 56. It doesn't matter because all the sides are proportional. So I'm going to go ahead and use the 70 and 56. So 70 over 56 equals x over 50. So we're just matching up our corresponding sides. So next thing we do is we cross multiply. So this is 56x equals, and then we're going to multiply 70 times 50, which is 3,500, and then solving, we just divide by 56. So 3,500 divided by 56 is 62.5. So now to answer the question, since it's a word problem, I'm going to have a word answer. I'm going to say the distance between the two campsites is 62.5 meters. All right, so now let's take a look at a second example. So this is a 36-foot support wire for a 12-foot tall pole runs from the top corner of a building to a point on the ground forming a straight line. The length of the wire from the top of the building to the top of the streetlight is 16 feet. We want to know how tall is the building. So I'm just going to label some things. So first of all, the support wire is 36 feet long. So this length right here, from here to the bottom, is 36 feet long. And then we have a 12-foot tall pole. And then we know that the length from the wire from the top of the building to the top of the streetlight is 16 feet. So that's from here to here, that's 16 feet. We want to know how tall is the building. So we'll call that X. Alright, so anytime you have overlapping triangles, I do want you to draw them separately. So I'm going to draw the big triangle first. So on the big triangle, we know that this is 36 feet, and I'm solving for that vertical height, which is X. And then the smaller triangle, here's what I know. I know that this vertical distance is 12. The thing that I don't know is I don't know this length right here. So this length is right here. Well, to get that length, if we know that the whole big hypotenuse is 36 feet and this is 16, we can subtract to get that length. So this is going to be 36 minus 16, which is 20 feet. So the hypotenuse here is 20 feet. Now that I have my triangles drawn, now I could just match up my corresponding sides. So it's going to be the verticals and the hypotenuse that match up. And now I can set up my ratios. So it's going to be X over 12 equals 36 over 20. So now we cross multiply. So this is 20x. And then 36 times 12 is 432. And then last thing, we're going to divide by 20. We get x is 21.6. So to answer the question, we're going to say the building is 21.6 feet tall. Okay, so another way that we can apply similarity is using a method called indirect measurement, and this is basically a way that we can measure tall objects without actually having to physically measure them. So for instance, a tall tree or a tall light pole, we don't have maybe a measuring tape that's long enough, so what we can do is we can use what's called the mirror method or the shadow method in order to do this. Well, when you use the mirror method and the shadow method, you end up with similar triangles, and you can do basically what we've been doing, set up your ratios and cross multiply to solve. So let's take a look at example 3. It says to measure the height of a flagpole, you place a mirror somewhere between you and the flagpole. So here's the mirror. You are standing 70 feet from the flagpole. So if this is where you're standing, you are 70 feet away. The height to your eyes is 5.5 feet. So this is 5.5. And you are standing 10 feet from the mirror. So this distance right here is 10 feet. We want to know how tall is the flagpole. Alright, so we have two triangles here. I know my dimensions of my smaller triangle. I have 5.5 and 10. For the big one, we know that this is x, but the distance from the flagpole to the mirror is not 70. The distance from the flagpole to the mirror, we have to subtract 70 minus 10, because remember, 70 is how far you are away from the flagpole. So 70 minus 10 is 60. So that's the measurement we're going to use across the bottom. So matching up our corresponding parts, it's going to be the vertical over the vertical equals the horizontal over the horizontal. So it's going to be x over 5.5 equals 60 over 10. So we cross multiply. 10x equals 330. And then we divide both sides by 10. So x is 33 feet. So the flagpole is 33 feet tall. All right, let's take a look at one more example. So this one's using the shadow method. So it says to measure the height of a flagpole, you stand in the flagpole shadow so the tip of your shadow matches up with the flagpole shadow. So basically here's a flagpole shadow across the bottom, and then you're standing in the flagpole shadow so the tip of your shadow matches up. So your shadows basically overlap. The length of your shadow is 10 feet long. So this down here is 10 feet. And you are standing 12 feet away from the flagpole. If you are 6 feet tall, how tall is the flagpole? All right, so I have overlapping triangles, so I'm going to draw them separately. So starting with the big triangle, I know that this is x. Across the bottom, this is 12 feet and this is 10 feet, so together that makes 22 feet. So the bottom of my triangle is 22 feet. And then I have my smaller triangle, which is you and your shadow. This is 10 feet, and this is 6 feet. So now that I've drawn them separately, now we can easily set up our ratios. So it's going to be x over 6, so it's vertical over vertical equals shadow over shadow, so 22 over 10. And then cross multiply. So 10x equals 22 times 6, 132. Divide both sides by 10. So x is 13.2. So the flagpole is 13.2 feet tall. Okay, so now let's take a look at a few of the practice problems. So starting with number 2, it says triangle EFG and triangle QRS are similar. So I'm going to start, there's no picture, so I'm going to go ahead and draw these. So here's EFG, and it doesn't matter how you draw them. And here's QRS. The length of sides of EFG are 144, 128, and 12. Or 112, sorry. And the length of the smallest side of QRS is 280. So the smallest side I'm going to put down here, this is 280. We want to know what is the length of the longest side of QRS. Well, looking at the red triangle, we have our small, medium, and large, and we know that we have our small side of our other triangle. So to solve for this, we know that we need to solve for the longest side, which we're just going to call x, and that's going to be matched up with the 144 because that is the longest side of the first triangle. So setting up my ratio, it's going to be x over 144, so those are my long sides, equal the small over the small, so 280 over 112. Remember, when you set up your ratios, you need to make sure that the top numbers are coming from the same triangle and the bottom numbers are coming from the same triangle. So x and 280 come from the blue triangle, and 144 and 12 come from the big triangle, or the red triangle. So now we can cross multiply. So this is 112x, and then 144 times 280 is 40320. And then we're going to divide by 112. So we get 360. So the longest side of triangle QRS is 360. So we don't need units here because there are no units. All right, let's look at number 7. So it says Carla looks from a height of 15 yards on top of her apartment building. She lines up the top of the flagpole with the curb of a street 20 yards away. And if the flagpole is 12 yards from the apartment building, we want to know how tall is a flagpole. So the height we're looking for is here. So I see overlapping triangles, so I'm going to draw them separately. So I'm actually just going to draw the smaller one here. This is X. This bottom part of the triangle, we don't know, but we know that this whole length is 20 and this is 12. So we can just subtract 20 minus 12 is 8 feet, and that's going to give us this bottom part. Okay, the other triangle we have is the big one, which is here. And we have those dimensions. That's 20 and that's 15. So using these two triangles, my blue triangle here and my big red one, we're going to set up our ratios. So it's going to be X over 15. So that's the vertical over the vertical equals the horizontal 8 over the side that matches up to 8 is 20. So now we cross multiply. So 20x equals 15 times 8, which is 120. And then we can divide by 20. So x equals 6. So the flagpole is 6 yards tall. All right, the last one here, we have Carla again. She's looking from the top of a diving board and lines up a ball floating on the surface of the water with the bottom of the opposite corner of the pool. We want to calculate the total distance across the surface of the pool. So we're looking for this distance right here. Okay, well, we have two triangles. We know that these are similar by angle. Okay, this triangle right here is the first one. In order to figure out the total width of the pool, I know that this is 9. I'm going to have to solve for this length right here. So that's what we're going to call x. Okay, and then we have our other triangle here, the 9 and the 12. All right, so setting up our ratios, I'm going to match up the vertical with the vertical and the horizontal and the horizontal. So it's going to be 12 over 10 equals x over 9. Cross multiply, so 10x equals 12 times 9 is 108. And then I'm going to divide by 10. So I know that this length right here is 10.8. So the total distance is going to be 10.8 plus 9. So it's going to be 19.8 feet. So the distance across the surface of the pool is 19.8 feet long.